Hi everybody. I want to get another look at the perpendicular bisector question. In regular school before the pandemic, we would practice this several times in class. So you're going to get to see me watch it. You're going to watch me do a couple of them, and you're going to do a couple of them before we ever put it on a test. But I do think the perpendicular bisector question has a place on the next test that we take. So let's practice. And practice makes perfect. I'm going to graph these couple of points, but you don't got to watch me. And I'm going to put them on that graph and label them. So I got P and Q in place. We ought to show segment PQ. That's what I'll do right away. Hope you got a straight edge. You lay them right on there. We'll get a look at that segment PQ. Let me get all the way to Q right quick. There we go. And it asked me right away about the slope of PQ. And we're going to need it, but you might be thinking, well, the slope of this, would it be positive? Would it be negative? Would it be a large number? It looks like it's going to be positive, but and not very large number. You'll remember that slope is delta y over delta x. Change in y over change in x's, which with this pair of numbers would be, well, with the y coordinates on top, 4 minus 2 over, use that y guy first, got to use that x guy first. That's important. People can't switch those around. 5 minus negative 3. And that just gives me 4 minus 2, just about 2, over a positive 8. We ought to call that 1/4. But because the slope is so important, let me check on it and see if I got that slope right before I go screw this question up. Does it look like it going up 1 and over 4? Up 1 and over 4. I'm guessing it probably does go up 1 and over 4, yeah. Something about like that. It doesn't look bad. And then it asks me to give the slope of a line perpendicular to our line PQ. I might make that look like segment PQ right there. And you'll be thinking, well, the slope of a parallel line, it's not asked for here, but it's a nice thing to think about. A parallel line would have the same slope of 1/4. Didn't need to write that, but what about the slope of a perpendicular line? What a nice way to denote that. Yeah, that ought to be the negative reciprocal of this number. And the negative reciprocal of 1/4 is a negative 4 over 1. So let's take this little walk. Give the coordinates of the midpoint of segment PQ. And you got to be remembering that, how do you get a midpoint anyway? The average of the x's, x sub 1 plus x sub 2 divided by 2. That'll be the x coordinate of the midpoint. And then y sub 1 plus y sub 2 divided by 2 will be the y coordinate of that midpoint. Let's do it with these couple of points and see if we can't get that midpoint just right. It's important. So that would have been x plus x would be 5 plus a negative 3 divided by 2, comma, 4 plus positive 2 divided by 2. Just using these x and y coordinates here, adding up the x's, dividing by 2, adding up the y guys, dividing by 2. That would give me 5 plus a negative 3. That's just 2 divided by 2. That's going to give me 1, comma. And 4 plus 2, there's 6 divided by 2. That's going to give me 3. But because I've been known to make a mistake every once in a while, I'm going to go over 1 and up 3 and see if it looks like it's the midpoint. 1, 2, 3. And I'm thinking that's probably pretty close. I'm going to call it M just for grins. We may not need to, but I'm going to call it M because people like to do that. There's my midpoint. Looks okay with me. Show the process as you find the equation of the line through the midpoint, which is perpendicular to segment PQ. We got that formula, and we know what slope to use. We'll use the slope of the perpendicular line, because we want to get that perpendicular bisector. And the perpendicular slope was negative 4 over 1. This had a slope of 1 over 4, but a perpendicular line would have a slope of a negative 4 over 1. Big deal. And we're going to go through this point, the midpoint. Don't use P, don't use Q. We don't care about the line that's perpendicular through P or Q. We care about the one that goes through the midpoint. People often use those, and that's a bad mistake to have. Let's go through the midpoint at 1, 3. I already got the formulas. I'm just going to whip right through it. Y minus 3 equals negative 4 times x minus 1. Let's see what happens there. y minus 3 equals, multiplying through those parentheses, negative 4 times x. Yeah, negative 4x. And a negative 4 times a negative 1 would be a positive 4. And as we isolate that y guy on the left-hand side, I got to add 3 to both sides of this equation. And that would become y equals negative 4x plus 7. That's what I think is the equation of the perpendicular bisector of this line. But I make mistakes, so I'm going to graph it and check it. Really, an important idea is every time you make a decision, go check it on that graph, because you're going to make a mistake, and you can find it when you make that mistake, and fix it before it gets out of hand. So let's go to that graph and see how it looks. The y-intercept of 7. I'm going up 1, 2, 3, 4, 5, 6, 7, right about there. From there, we'll follow the slope. The slope tells me to go down 4 and over 1. So what I'll do, go down 4 and over 1. Looks like it takes me to the midpoint, which I'm happy about that. I'll show that line between those 2 points and declare it to be the perpendicular bisector segment PQ. Make it a nice long line. I think we're going to find some interesting points on it. In fact, I think I've got to bring it a little further south. Let me do just that. Having looked at this exercise, having written it a minute ago, bring that line a little further down. Okay. Now it tells me there's a point Z somewhere on this perpendicular bisector. And what you're thinking is, hey, this line right through there, that long line, that is the perpendicular bisector. It is perpendicular. We got a right angle right there. And this segment has been bisected. We struck it at its midpoint. Kind of nice to mark it like that. And we're going to find the coordinates of this point Z that is on the perpendicular bisector. It complete its coordinates, and the x-coordinate is 5, and let's try to figure out about that y-coordinate. You might say, well, I'll go over 1, 2, 3, 4, 5, and how far down do I got to get on that line? And somewhere around here, but I really don't know. I better use up some algebra, and I really want you to use the algebra anyway. So this equation that we have written is the formula that gives you y when you know x. Let's put it to work. Y will equal negative 4 times whatever x is plus 7. And we want to let x be 5 this time, don't we? So we'll substitute right there. We got y is equal to negative 4 times 5. There's a negative 20 plus 7. That'd be y equals negative 13, wouldn't it? A negative 13. So I'm going to play that right there. Say y, that point Z should be 5 comma negative 13. And go take a look. Is that okay? If I went to the right 1, 2, 3, 4, 5, and down, that's 10, about 13, be about here. I'm thinking that's probably about right. There's that place, 5, comma, negative 13. That's our point Z. I'll put a Z right there. Now, we're going to figure out a couple of distances. But this is an interesting thing. Over here, this point P had coordinates 5, comma 4. And you might think, well, isn't that interesting? This has the same x-coordinate as this one. That would mean that these points are vertically aligned over 5 and up 4 and over 5 and down 13. Man, they're right on a vertical line there, aren't they? And so you probably already know the length between of those two. It would take you 4 to get to here and 13 to get to there. It must be about 17 units right there. We'll hit it with the distance formula in a minute and give that a look. So that's what we ought to do next. We're going to go find the length of ZP and ZQ. Let me make that note right here. ZP is what I'm looking for here. And when you look for a distance, you ought not put a segment marker on them. Sometimes I forget to put them on there when I'm typing it up. But when you're looking for a distance, you ought not. And we're going to also look for ZQ. And you're thinking what I'm thinking, these things should be the same. Let's take a look up here. Should they be the same? This distance from Z to Q, does it look like it's going to be about as big as it is from Z to point P? Let me get that picture too. I'm thinking they look like they might be pretty close. So yeah, I'm thinking they are going to be the same. Let us instantiate that right here. Remembering, where was point Z, mister? Well, point Z was at 5, comma, negative 13. And point P was given at the top of the page to be at 5, comma, 4. These are the points that were vertically aligned. Had the same x-coordinate. And that's going to make it really easy to use that distance formula. We might already know the length. I just set out these couple of, this square root and a couple pairs of parentheses, and I squared both of those parentheses. And you might be thinking with me, in here we're going to put the difference in the x's, and in there we're going to put the difference in the y's. So let's roll. 5 minus 5, quantity squared, and here, negative 13 minus 4, quantity squared. Couple places to be careful. That's just 5 minus 5. That's just going to be 0 squared. And a negative 13 minus 4, since they're both negative, we're going to add them and get a negative answer. It's going to be negative 17, also being squared. Hope you're thinking what I'm thinking. Well, 0 squared is just going to be 0, and negative 17 squared is positive 289. That's just 17 times 17 is 289. And so maybe you know the square root of 289, huh? Yeah, that'd be about 17. We might measure this thing in a minute, see if it looks like it really is 17, but that's what I'm declaring right there. Now let's get ZQ. And I'm hoping strongly that ZQ is also equal to that amount, 17. That's what ought to happen. Let's see if we can't make that happen. Where was Z anyway, mister? Well, Z was at 5 comma negative 13. We figured that one out. And where'd you keep Q? Oh yeah, Q was given at the top of the page to be at negative 3 comma 2. Looking carefully for minus signs, because I could make a mistake. I've done it before. Negative 3 comma 2. And here we go. Let's hit it with that distance formula to see what comes. Going to put the difference in the x's right there. Going to put the difference in the y's right there. Going to figure out that length. We're calling it ZQ. So in the first pair of parentheses, 5 minus negative 3. Yeah, that's the difference in the x coordinates. Here comes the difference in the y coordinates. That'd be negative 13 minus 2. Just y coordinate minus y coordinate. And here, x coordinate minus x coordinate. But there are lots of minus signs to be careful with, huh? Let's be kind of careful, see what comes. I've been known to make a mistake around here. I'll try to be careful. I see 2 minus signs on the same number right there. That's going to be 5 plus 3. That's going to be 8 squared. And a negative 13 minus 2, that's really a negative 15. When they're both negative, you got to add them and get a negative answer. But we're going to square it, so it's going to go positive. You're not going to ever end up with a negative inside this radical. It's going to always be positive, because we're squaring stuff, and square things are always positive. 8 squared, you know, to be 64. And 15 times 15 is 289. Excuse me, 225. I got a little ahead of myself. If I add these up, I'm going to get 289. But 15 times 15 is 225. A negative 15 squared is a positive 225. Add those up and you got 289. Lo and behold, that's what we thought for the other length for ZP. And ZQ, both of them square root of 289, so both of those are 17. And you should expect them to have been equal in length. That is a property of a perpendicular bisector. Now let me just have a little fun for a second, please. I'm going to figure out what 17 looks like, and I think that's probably, you count over here. I just counted out a length of 17 from here to here, from this place to that place. I knew that this was 10, and that's about 7 right there. So I'm thinking, well, that length should be 17. I'm just going to make a mark on this other piece of paper that should be the length that is 17 on this graph. And I'm just kind of playing around. This is not something you got to do, but I think it's a little bit interesting. I'd like to show it to you. So if that length right there between those two marks is 17, and these lengths are supposed to be 17, how close is this going to be? Let's give it a look and see what happens right there. And lo and behold, it's pretty close, isn't it? Looking at ZQ, going to be about 17, isn't it? Now, this is not the way you're supposed to answer this question. We're just going to confirm our answer. And ZP, yep, that's the same amount. Those are equal to 17. So this worked out just like it should. Now, don't expect it's always going to work perfectly for you. You're going to make a mistake from time to time. You just got to check your work, go back and find your mistake. And it's a great exercise. So, after watching me do this one, you go practice with that other one. Thank you. I appreciate that you would. See you soon.